Hello, this is David Birch at Starpath School of Navigation in Seattle with a short video note on the Bayes Ballot Law. This is fundamental to marine weather, and its applications comes up many times, and I want to show another excuse me, I've got a sore throat today. Another application having to do with reading weather maps. But the basic law is simply that it's how to find the direction to the low if you have the surface wind. So you put the surface wind to your back, you put your left hand straight out, and then slightly forward. And that's forward 20, 30 degrees, and you're pointing into the low. That's the Bayes Ballot Law, actually discovered by an American, William Farrell, but he doesn't get credit for it. Here's another case. Here's the winds going around a low, and back to the, it's the same thing all around the circle. So back to the wind, left hand out, slightly forward, and you're pointing to the low. So that's the basic Bayes Ballot Law. Some people do it with the other hand, but they really shouldn't do it that way. This is the way it was originally published, and we probably stick to that as best. So let's go to a simple case here of just a weather map. So here's a weather map, and what I'm getting at, what I want to get to is how you use Bayes Ballot Law in a very simple way to find the direction of the wind based on the lay of the isobars. And in many situations with weather maps, we have to do that because we get some weather arrows here, and in other maps, like the forecast maps, we don't. We'd have to rely on separate maps for that. So here's, for example, here's a high, and winds go clockwise around a high and counterclockwise around a low, and it's basically the same rule. So sometimes we rely just on that rule. If you want to know what the wind direction is here or here, somewhere like that, it would be clockwise around the high, counterclockwise around the low, and then slightly into that low. That's that angle we're talking about of 20, 30 degrees into the low. So the winds flow around that way, counterclockwise around the low, around these isobars. So first order is parallel to the isobars around here, but not strictly parallel. They go into the low, into the low. And in this case, around the high, they should be going into the high. So this wind, if you had to guess the wind direction here, it'd be going this way around this high, and then into the high. So that's in a real clean, simple, with big H's and circles and things like that. It's very easy. Usually very easy. But now let's look at the case at hand here. Let's look at you say you have a case of isobars like this. Now here's the example we're going to do. We're just going to pick out the wind direction in various cases on this map of just plain isobars using the Bayes Ballot Law. And so let's just see here. These have labels. Well, they don't have labels very often. Anyway, this is 12. I can also read the pressure over here. So this is 12, this is 14. So this is 12, this is 14. So the way you would do that, here's a very simple picture on how to do that. Let's say you want to know what the wind is right here, what the wind direction is right here. Now we're not dealing with the speed. The speed has to do with how close they are and the latitude and a couple other minor factors. Those are the big ones. But right now we're looking just the direction. Just the direction. So you want to know what the wind is right here, wind direction right here is. So you just imagine you stand here and you grab with your left hand the low one. This is the 12, that's the 14. So you grab left hand, grab the low one, right hand, grab the high one. And then you are looking in the general direction of the flow of the wind. And if you want to hold hands on these isobars and walk around here, here's your left hand holding this guy. Now see, I don't know where, maybe the high's up, or what is it, a low or a high? It's a low. There's a low up here. But I'm not even worrying about that. I'm just looking at these two isobars right here by themselves. This one's low and this one's high. I grab my left hand on this one, my right hand on that one. I'm looking that way. Then the wind is going this way. So it's likewise, if my left hand is here, right hand is here, the wind is going this way. But then we fine tune that. It's not going just this way, it's going a little bit into the low. So the wind direction here, you wouldn't say is this direction like that. You would say it's more like this direction. You know, something like 335 or something like that, 340. Be that direction like that. Crossing these isobars slightly into the low. Like that. And then you can just hold your hands, and if you hold your hands here, you'll see the wind still going this way. When you get down here, it's still probably going more or less this way, but it's farther apart, so it's weaker here. And here the wind is probably going to be coming around here on some level, like that, still into here. These cases are even simpler. The left hand's here, right hand's here. It's just stronger wind going this way and that way. And we could just flip on the wind for a second to look here, and you see that. Out here the wind, now it doesn't show it quite, it doesn't really show it crossing the isobars as much as it should, but really as you get, look, see when these get a little tighter here, these are definitely crossing in, or should be crossing into the low, some direction into that low. Be a little more prominent when you get in here. But generally it should be slightly into the low. See, like these guys, into the low. So that's the way that works. So let's just shut that off for the moment. And then go over here. Now, what do we have here? Here is a, what's that, 1014 millibars, 1012 millibars. So here's the low. I don't even have to turn around. I put my left hand on here, my right hand on here, and that's the way I'm looking. That's the way the wind's blowing. With the low isobar in my left hand and the high isobar in my right hand, and then slight. Oh, now wait just a minute. This is 14, 12. No, it's still into the low. So this is another low. Ah, that's interesting. This area is then a call. See, because there's a low here. This is 1014, and that's again 1014. So, but let's stay here for a moment. So it's low. So the wind's coming around here like this, and all the time not parallel to these isobars, but slightly in. Like the wind direction here would be a little slightly in, and so on. Same way down here. Left hand, oh well, what's this guy? He's 16, he's 13. 16, 16, 13. Yeah, left hand here, right hand here, the wind's going that way. And if I just take a quick look, we should see that. And sure, and also you see the general principle. This is a little bit further apart here than they are here. And so the wind out here, you got like nominally 10 to 15. Here you have like 20, 25. And there's actually a weakness here that we can understand because there's a curve, but that's not the subject now. It's just bending around like that. And go back, shut off the answer sheet. Now, what's going on? Let's look at this case. What's here? Let's say we want to know the wind somewhere in this area, right in here. Now, to first order, this is 1016, and that's 1016. This is a ridge of some kind. So even though this says 1016, you can't really believe that it's 1016 all across here. This is a ridge. It's a ridge of high pressure sticking up here. Somewhere down on the bottom, there's an H somewhere. And this is just an elongated part of that H. But that's almost a point at hand. Now, let me just see to what extent we can do this. I should have cheated and looked at the answer. But let's say this is now, that's 16 all the way around. I'm saying this is a ridge, so that means it's going to be slightly higher here. Let me just call this 17 for now. 17. So if I grab my left hand on the low one, and my right, that's 16, and my right hand on the 17, then this wind is going this way. See, I'm just drawing a line here. I'm just drawing a line somewhere in here and saying that's going to be about 1017, somewhere in here. 1018, I don't know what it is. Probably, if there's no more isobar, it's probably not more than another millibar. But that's about a millibar. So 1017. So I got a left hand here is a 16, here's 17, so it's going this way. So the wind's somehow coming up this way. But now on this side of the thing, I've got my left hand here That's 16 and 7, right hand, left hand here. So this wind's going this way. I'm looking around like that way. So the wind is somehow going up and somehow coming down. Now it's going to be a little bit fluky to even, you wouldn't want to bet very much on what's going to happen. But if you had to bet on what's going to happen in this region, it's going to be kind of wind going up this way and definitely lighter in the middle and somewhere stronger along the edges. So let's have a look once. I wish I would have, not bad. Not bad. So you see it is really kind of fluky in the middle. Now this machine, if this were, depends on how good the, oh, look at that, 1017. Watch the pressure here. You see, even though there's no isobar, oh, there, 1017, 1017. So it does go up about 1 millibar right in the middle, even though there's no line or anything. So that does that. So that's the process. Now in this big call here in between, a call means, you see you got 1016, 1016. That's two ridges coming down out of the sky here. Do we see anything more there? Oh yeah. There's a ridge here, and then there's two lows here. I can't see it. Well, I don't get them on the map. Well, you can see that was obviously there. But this, anyway, two lows and two highs. Now, that's going to be very difficult to predict the winds in here. If one had to make some guesses, we could. But you see, this rule for finding the winds in this area is still right. This is 16. This is 14. So I grab the low one in my left hand, the high one in my right hand, so I know generally the wind is coming down in this direction. And when we get when the isobars are not parallel and not really closed like this, we have to be a little flexible on how much the angle into the low or out of the high. You see the same thing here. That's going to vary a little bit, or vary a lot, up to 45 degrees actually. But you're always going to have here, and this is a high, and this is a low. So you see, just one last point, and then this exercise is over. You see that obvious case that out of the high, like crossing the isobar out of the high, this is a high, a ridge. So crossing out of the high is the same thing as crossing into the low. Into the low, out of the high is the same. So the main point I wanted to make, primarily because of questions that came up in class or in our online course today or over the weekend, is that finding the wind direction on a map, on a weather map, all you need to know is the isobars. You don't have to have big H's and big L's printed on the page, and you don't have to have closed circles. Like we almost have a closed something over there, but let's get rid of it. That's my point. In the Bayes ballot law, grab the low one with your left hand, the right one on the high one. Right hand on the high isobar, left hand on the low isobar, and you are facing the direction of the wind. The direction the wind is flowing toward. Okay, that's the end of that. Bayes ballot exercise.